panel discussion of the day that will focus on performance optimization and overview of best operation and maintenance strategies, mitigating challenges, and the way forward. I would once again invite Mr. Chandrasekhar. You all have just heard him, and as he mentioned, he's going to be moderating this session for us. And joining him would be the panelists. Request you all to put your videos on as I call out your name. So we would first welcome Mr. Prabhat Kumar Sinha, Senior Consultant, Energy Sector. Mr. Sinha currently works as an independent senior consultant advisor to premier consultancy houses and power utilities for on-site and off-site advisory for gap analysis, performance improvement, digitization, and sustainability matters. He is also an active trainer, evaluator for technical upskilling for executives at institutes and power utilities. Mr. Sinha has hands-on experience of 36 plus years of working in NTPC and its joint ventures. He has also held the position of Executive Director at NTPC as Head of Safety, Sustainability and Environment. As a CEO of KBUNL, a JV of NTPC with Bihar government in power generation space, and whole-time director at NTPC GE Power Services, a JV of NTPC and GE. Welcome, Mr. Sinha. Next, I would like to introduce Mr. Kamal Kishore Mundra, partner and trainer, thermal power ex-NTPC. Mr. Mundra has 41 plus years of experience with NTPC and major original equipment manufacturer service providers in all spectrum of operation and maintenance in India's best operating coal and gas power plants. He has been instrumental in implementing world's best power plant practices and systems for performance enhancement. Has supported Chinese supercritical and BHEL make subcritical power plants managed by state energy. He has also conducted various online training programs and has been actively engaged in skill imparting in emerging power scenarios. Next, we welcome Mr. Pradeep Kumar Bandyopadhyay, independent consultant, Steg Energy and Toshiba JSW. Mr. Bandyopadhyay has 34 plus years in O&M, consultancy, EPC, MNC, and IPP route in the field design, engineering and management, proposals and estimation, feed, procurement, commissioning, and troubleshooting. Some of his previous experiences include Doosan Power Systems India, Jindal Steel and Power Raigarh, GE Power India Limited Durgapur, Tata Steel Rourkela Steel Plant, and India Bulls Power Services. He is currently working as consultant with Steg Energy Services India and Toshiba JSW Power Systems and is involved in various projects owned by Vedanta Alumina, Mahajanco, GSECL, APPDCL in Andhra Pradesh. And I would also request Mr. Upendranath Bhupal to join us. He is the Vice President, Technical Spectrum Techno Consultants. Mr. Bhupal has an overall experience of 27 plus years. He has spent his initial years of work in a thermal power plant, and in subsequent years of his experience has been dedicated to cooling towers. He has worked with Bakaldur and is presently a consultant to the cooling tower industry. We will have Mr. Sinha make his presentation first, followed by Mr. Mundada, then Mr. Bandyopadhyay, and then Mr. Bhupal. Please note that this is mainly for the attendees. You would see a Q&A box at the bottom of your screen. This is for you to key in all your questions for the event. So you could do it in the Q&A box. I will use the chat box for any interactions that you and I have to have with each other. Each panel member would have around 35 minutes to make their presentation, followed by 5 to 10 minutes of a quick Q&A with Mr. Chandrasekhar for discussions and from the audience. I am just giving you the rights to share your screen. Yes, so you could share.
Thank you very much, Shreyal, for warm welcome introduction. And I appreciate the entire proceeding which has happened till now, and it has set a tone very nicely. The session moderator, Mr. Chandrasekhar, our co-speakers in the panel, I am really delighted to be with you all. So going forward, the current scenario in this country is the situation which is giving this particular type of session to be live and very pertinent one. So okay. So can I?
Oh, yes, we can see your screen. You could just go to the slideshow option.
Okay. So is it visible now? Yeah.
Yes,
thank you very much. So very rightly said by the speakers till now, and the session chairman as well, that yes, the things today are in a scenario, in a situation wherein we have to be very apt towards our actions, because the country is moving ahead very fast as per the pace set. And also, in order to give a will to this growth, power is one of the key ingredients. At the same time, we have a set of power plants. As we all know that the total installed capacity is some 400 gigawatt plus, and in order to meet the requirement of this growth, we need to go to up to 800 gigawatt plus till 2030. But what is happening is that this 400 gigawatt till now has been constituted by vintage of plants. There are units which span from 30 megawatt to 660 or rather 800 megawatt. So the balancing has to take place. So has to take place with respect to generation. And what we see with respect to the generation perspective and the current generation scenario is that despite of having a 400 gigawatt capacity installed in at this moment, we are not able to meet a requirement of 210 gigawatt. So this is what is the situation today. Of course, the reasons are many, but this particular session, I hope that we'll be able to address, and particularly my focus area is that only. Yes, we have a set of power plants, but the key and the backbone of entire generation depends upon the old and vintage plant, which are pulling back the generation because of various reasons. Because of their drawbacks, their shortcomings, their lack of design, whatever. We'll talk in the coming sessions. At the same time, there are many other external factors. So, as in this session, we can see the hours as the key aspects, which I will be also touching, is that performance optimization based on a strategy mitigating challenge and way forward is what is the session requirement also. But being an entire requirement to uplift the power scenario in the country, of course, I will be touching the overviews of many things, and to be precise in my particular viewpoint, I will be touching two things which I want to make it out right. It's here itself that the most important thing, as I said, is the backbone. The why we are not able to meet a 200 gigawatt of requirement, even though we are having a set of 400 gigawatt capacity in the country. So naturally, that calls for upgrading, or the name can be different, but of course it has to be brought up to the level wherein it is able to meet the requirement as and when required. So I call it R&M or upgrade, or you can say that retrofit. But these are interventions, I say. And another point is that when we say upgrade or upliftment or meeting the current scenario, the other important factor which is pulling back the generation, or which is pulling a pressure upon the thermal plant, is the introduction of renewables. So there are many key points. There are many key issues with respect to that, which we'll discuss. So in order to meet that scenario of varying load, change of requirement, decentralized generation, so the operation and maintenance both have to be very much congruent, and both have to be in a situation which can be backed by AI or the digital things. So my focus will be to talk more upon the upgradation, retrofit, and operations to meet the operation requirement of the current scenario, and also the digital need, which can really create a platform to match the current scenario, the modern scenario of introduction of renewables. So, setting the tone in this line, I will take you to the my takes is that if you go by the current scenario, or what are the drivers? I mean, if we talk about performance optimization, so what do we need? Why do we need to do it? There are two perspectives which I will say, which I see rather in my in the current scenario. One is that the power producer. The power producer is facing today a scenario wherein it has to be relevant. It has to be very competitive with respect to the cost of generation. Because if you are not performing well, the changing scenario in which the power plants performance, and in the very recent time their generation capability and their, you can say, the ratings are also being established, or more so the generating people are fully aware that you have to be very cost competitive, except certain period in which all cost of generation can be absorbed, which was a scenario last year and which may be coming this year also because of the crisis. But that is crisis driven. But those periods are very short. So that cannot be a generalized things to run a power plant. Then another important and critical survival issue is environmental compliances. Of course, India is biased, and the rather world is biased, and as a citizen, we also know that the kind of drive India has taken and the world has taken to reduce the environmental issues, to contain the pollutants, which is directly related to the thermal power plant or the coal-based power plant, from wherein we get it very in a quite a substantial manner. And then the third thing, as we discussed, is renewable integration and distributed generation. Earlier, thermal power plants were set up in a scenario wherein it was centralized generation. You can say they were the base plants which were supposed to supply power plant. But today, with the introduction of renewable power, even the generator, even the consumer has become a generator. It's not like that there will be power plants which will be simply supplying to the consumers. The things are getting distributed, and the impact is there because they are also hooked up to the grid. So naturally, that scenario is changing, and the power plants have to bear those variations also. And that entails, in my last point, is a cyclic load demand. So this is what is a scenario in which the power plant, thermal power plant typically, for which we are talking about, is that they have to bear all those cyclic demand with respect to their capability utilization, with respect to their performance utilization, and remaining at their best performing level, and also saving the power plant with respect to the damages it is facing because of cyclic loads and the distribution generation, and also to match the pumping of load within that. Okay. And the stakeholders, of course, they are also becoming very, very key drivers in this particular performance optimization, is that they want reliable supply and also available for supply. So the generator or the power producer cannot remain complacent that I will supply as I want, but then everything is being driven by the stakeholders, rather I will say. And all these with respect to the earlier scenario of power production, the today's scenario is entirely changed. Entire gamut has changed. So within this complex scenario, the performance optimization becomes more challenging. And with respect to that, if we focus upon this area, my take is that the performance of a power plant, which directly affects a producer, is mainly focused upon the three key areas. As you can see that the boiler and the generator, and rather the maximum losses which are taking place in the cold source loss, or what we say, we can call it, the other name is that the steam cycle and the water cycle. So these three areas should be the focus area wherein the most of the losses are taking place. And then Ultimately, the thermal efficiency of a modern power plants remains between today's scenario 35 to 49, and the vintage plant they may go a little bit lower, but then the containment zone is within this range, 35 to 49%. So therefore, my take is that with respect to the performance, optimization to the power plant, is that we should focus in this area, wherein the maximum, as we say that if you pick up the three major area which consumes maximum investment or maximum cost of running or cost of operation, is these three areas, and also these three areas contributes maximum towards the non-performance of the power plant. So naturally, our first attention should be to these areas. So therefore, with this perspective, what we do today is not enough, what I say, because the standard practice is that each plant and equipment comes with a booklet. Other than the human being or the any other living things, every equipment which takes birth comes with a maintenance manual tagged to it. So the manufacturer is always there guiding us with the booklet, and they provide us the methodology for with respect to that. If you follow those things, naturally the plant will run as per the expected performance, and it will live its life as per the as designed by the manufacturer. And so is the process which has been defined by the manufacturer. So out of the 7 maintenance practices which power plants are adopting, which is listed out here, the preventive maintenance is given by the equipment manufacturer, which we follow mostly in the power plant. Then the predictive maintenance, reactive maintenance, these are the names which has come up with respect to the recent times practices. And the most modern practices which has come up is condition-based maintenance, wherein we go for the, these are the different school of thought, which has evolved over a period of time. That yes, we need these type of maintenance in order to ease our life, and in order to avoid the failure, in order to keep the equipment up. The most modern practice which has been is that risk-based maintenance, which has come up with respect to the evaluation, AI-based evaluation or digital evaluation processes, or it can be clubbed with the, you can say that the process of asset management, into which these things are tied up, and these things are included. With respect to that, we go ahead to maintain the equipment. But with respect to the what we discussed in the previous slide, the variation which are taking place today in the last, I will say not today, in the last 6-7 years, when the economy is growing very fast, when the demand is increasing very fast, except the 2 years of this corona period, into which there was shortfall in the production on the growth. But then overall, if you see, it has picked up again very fast, and the growth rate has pegged around 6 to 7%. I don't give it a perfect number, but yes, 6 to 7%. When naturally the power requirement and the demand growth has also been the similar manner, and electricity requirement will also grow accordingly. But then with the aging power plant, can we go ahead with this sort of standard maintenance practices? I don't see, because my experience as it goes, these were very much pertinent to keep the things alive as per the standard practices. But then when so many variations, cyclic loads, aging, etc., various type of things are happening to the equipment. So these are not enough today. So naturally, when these are not enough, then what else? What are the challenges which equipments and plants are facing today, or the power stations are facing today? Uh, and the one of the reason I will mention here is that as a number, you can see that the current scenario in our country is that our power plants are operating, thermal power, coal-based power plants are operating at a plant load factor of somewhere around 60% only. So, I mean, there may be there may be some kind of restriction from the renewables, but more so, I believe that even though we are having capability, we are not able to match the requirement. Even 60% PLF, we are not able to match the demand. So naturally, there is some shortcoming in the operation of the equipment or the maintenance and upkeeping of the equipment. So the challenges is this, which is given out in this slide, and I have put it in a manner that yes. Nowadays, the operation and maintenance team cannot work in silos because of the challenges which we discussed. The operation team is facing the challenge that they have to negotiate fluctuating renewable energy, increased distribution, generation, efficiency, super critical, various type of issues which has cropped up, which were not foreseen earlier. But then we have all those assets with us, which have been serving to us, and still they have to serve till we completely age them out or we retire them out. But then all of a sudden we cannot switch off or switch on them. That okay, let us switch off the old power plants and switch on the new power plants. It is not possible, as we all know that the cost of installation and the cost of operation and the investment which is required. So it has to go in a very balanced manner. That is the reason the old power plants, aging power plants, the operation team are facing frequent change in operation mode, cycling of the plant, frequency control, technical minimum, all fast ramp up, ramp down. So with respect to that, the maintenance team is facing the challenge that they are not able to match those requirements because of the deterioration in the component and the reliability of plant, availability of plant, and operational safety. All three are getting affected because of those. So the challenge, such type of challenge, were not envisaged earlier, not planned, or rather I will say. These are coming as we are growing. So accordingly, the decision making has to be very fast with respect to that. So naturally, that is where comes is my take. When you are biased in such a scenario, what to do so that we are able to match the performance requirement and also match the energy requirement. Is that the one which comes in my mind and which is coming up gradually in the picture also, and is digitalization process. Means today the operation and maintenance are, rather I will say, they are working in silo. Let me put it like that. We have a operator in a remote ash handling plant or a remote coal handling plant, remote fuel handling plant, and an operator in the control room. We have manual operators. Various type of operations are taking place, and they are measuring they are recording the parameters, they are noting it down. Then the resources which are coming to the power plant. So all these things are working currently in a silo, whereas the decision has to be taken in the control room, because there it's a continuous process. So naturally, if we go for clubbing all of them, it may not be an entire end to end, but we can club various components together and take out the integration and the information from the set of those things. Say for example, if we have a coal handling plant and we need a input that what are the best quality of coal available and which is assaying coal block. So those things can be digitalized through a various processes, through AI, as it was discussed in the beginning of the session. We'll be seeing in detail also. AI can help us in those things. So that is one block which I feel can help in taking decision, and we can optimize the performance, which will avoid a delay in taking decision and deterioration in the equipment, or reduction in any performance. So that is number one. Number two is that, as I said, the upgradation or the retrofit. There are various names which are given with respect to their application. But then I am for those reasons. I am very much in support of those school of thought that operation maintenance can only do a routine things, whereas if you want to keep our equipment and plant relevant to the scenario, we have to think, we have to act, start thinking towards upgrading the technology, upgrading the equipment. With, of course, it cannot be done immediately. So in the few slides, I will take another 10 minutes. First, I will let me put it my views toward the R&M, and I, being in the core of R&M of major plants in my past experience, so I have seen the magic of R&M and retrofit. So going forward, I have not brought in all the case study, or rather none of them rather, but I will mention it here. But then let us touch upon the R&M area. As we can see that, yes, in a routine maintenance, if you see the simulation of, this is a work of a accumulated data of several power plants, that in a simulated condition of unit efficiency, the unit has efficiency has to go down in a very, you can say, the gradual manner, but it is sure shot it will go down if you continue with the regular maintenance practices also, as can be seen. You can see that in the kind of intervention what it is being done in between the different years of operation as per the standard practices. But then the aging process, there are two aging which are taking place in the entire lifespan. I have put up the entire lifespan considering, say, 25 years is standard. But the power plants which are of 10 years of age or which are of 15 years of age, they are also suffering those kind of aging. And those plants are again suffering the lack of performance. So what are the reasons? The moral aging of the performance is that the geometry of blade profiles, like in turbine, or the valve heads, or the geometry of turbine inlet or valves, or the old design limitations. So even if you want to stay relevant and be economical in generation, such things will pose a restriction upon it. Then the physical, like whatever best operation you do, because of the current scenario or the previous scenario, cyclic loading, and because of the many time going to the minimum load criteria also. So naturally, the change in parameters, that is one of the worst thing any power plant bears with, because of the metal components, which is of very high thickness, and they are undergoing various type of stresses, cyclic stresses. So natural stress are taking place, and then again the fluid which is flowing inside it, their constituents, it may not be always superheat. They may carry some water. So all these things put together, they create a scenario wherein a lot of aging may take place, and that is where comes in the natural degrowth or natural deterioration in the performance, which is shown here, and which manifests in the reduction in the efficiency or the heat rate, the other term which you use in the power plant. So whatever best maintenance practice you do, the power plant equipment and the system has to go down, be it in the second year of operation to 10 year or 50 year, or whatever year you go. Of course, this is just a model and a simulation, but then these are based upon certain facts. So even if you see in the current scenario, there are various data are available, and various publications through CE are there, that the plants which were of 200 megawatt to up to 500 megawatt, which has run for 15 to 25 years, there is a deterioration of heat rate of not less than 15 to 20% of that category. And I mean, you can understand. I need not say that what kind of loss for loss of performance those plants are bearing. So those things are established fact, and naturally the interventions at right moments are required. Standard practices should be there. Standard practices as preventive maintenance, predictive maintenance, those should be there. But at the same time, the plant operator or the maintenance team or the owners of the power plant should think in a I will say in a long term basis, so that a correct intervention is done in the power plant equipment and processes, so that the generation do not suffer and performance remains up to mark with respect to the deterioration which is taking place. So just one example I would like to bring in. This is I have been in the center of this study, is that there is one method of doing a turbine steam path study of turbine steam path aging. So in fact, this is the work of my team, or rather my involvement, is that which we saw in the previous slide, the aging of the deterioration of the performance with aging. And this is a typical example of a turbine which I have been involved in, conducted in various units. And I have seen that even though the heat rate deterioration, even if you intervene those plants in a say, these are the period of operation, 110,000 of, then 128,000 hours of operation. So even we go for capital overall of the turbines, the losses remain. This is the permanent loss. The pink color is the permanent loss. It remains even after overall. What we can make is that this blue color. So as we discussed in the previous slide, as I told about the natural aging process or the moral aging process. So whatever best you do, the losses in turbine will remain. So with respect to running hour, the permanent losses remain, and which is equivalent, it is shown in the what is the equivalence of heat rate and what is the equivalence of power loss. And ultimately it manifests in the cost of the production. So the point which I wanted to make is that now coupled with my earlier slide, is that if you focus upon the key area like turbine, this is one example. Similar applies with the boiler also. And more along with that, it applies equally and seriously upon the condenser area also. Of course, I am not covering the entire thing, but as we all aware that most of the heat is being dumped in the condenser. So maximum loss is taking place over there. Maximum, benefit can be drawn from there, as we all are aware that a small improvement in the condenser vacuum can add a very good performance level, which I believe other panelists will be talking about also. But then bringing you back on this slide, the turbine is the one of the main focus area, wherein the best maintenance practice even cannot bring you the best performance or cannot give you a sustained performance. Even a capital over cannot give you. So ultimately, this is what is my thought process and my understanding, what I just now said, is that standard maintenance practice will not suffice for a sustained performance. So for sustained performance, we must go towards a midway interventions through R&M, retrofit upgrades, and remain relevant in the league. So the point is that there is a misnomer that R&M means the plant has to take a 25-year or 20-year, then we have to revive it. So those are the old school of thought. my suggestion and my school of thought, my view is that very clear. R&M doesn't mean renovation, putting the entire plant under shutdown and then working on the each and every component. No, it's not required. Today, the R&M or upgrades are more relevant facts, are more relevant thoughts to bring back the equipment at a level so that we remain, the producer remains in a zone of being relevant to sell the power, to if you talk in terms of revenue, to be competitive, to earn upon the investment. As everybody, I mean, we are all aware, power plant is a huge investment. So naturally, the return has also be a very clear in our vision. Otherwise, no business runs without a numbers. I mean, profitable numbers. So, as we discussed in that, the reason of R&M is that simply that age structure, as we discussed, and the heat rate auxiliary, which are the key factors which drives towards the power plant performance. And also another key factor which we already talked about is the plant availability and force outage. All these things are addressed, but please don't take it R&M means that waiting for 25 years. These interventions can be distributed along with the age of the power plant. Like if I say that a small change in the control system, or the small change in the digitalization process, in the digital equipment, so that can make a big effect upon the plant performance. So the things, the C&I equipment which are aging, which are not relevant, which are taking a lot of failures, we can go ahead to change them with respect to the new generation equipment. So those are not very high investment value equipment. So going ahead, this is what I want to bring info in. So the usual process of thinking about R&M is that we have to go in a long shutdown period, a very huge cost investment. Whereas my thought process is that we can go do it in a staggered R&M or a staggered retrofit or a staggered upgrade. The model one is that we can go for a turbine, wherein the turbine, it's not necessary that we change the turbine in totality. We can go for a small component replacement, say like it's you can say that seal steam system, or maybe that upgradation in the condenser, maybe the upgradation in the valves. So it's not necessary. We can always list out the numbers, and then common jobs can be clubbed with them. Similarly for boilers. So what I am trying to say is that one model can be that we add on turbine, boiler, generator, take a longer shutdown and address them, and common jobs can be taken within that. Whereas a different model we can stagger those other maintenance, small maintenance area, and we can always plan those things with respect to the interventions required with respect to time, understanding the deterioration. But then, of course, the benefits are very much pertinent. I need not repeat upon that. But then when we go for such type of analysis, one of my thought process is that the plant performance should be assessed with respect to the comprehensive health assessment technique. So my point is that, my view is that it's not like that we have to only go for it's not only that we go for a larger, bigger maintenance framework, or we can always take a break in between the plant operation and maintenance and go for its complete health assessment and then make a menu card. Based upon that, we can decide run, repair, renovate, retrofit, and reject. These are very simple mantra I can say, which I have adopted in my previous practice, previous various R&M and upgradation jobs or while operating the plants also. So my point is that we must go for uh, this type of assessment wherein we go for complete the area can be divided in 5 categories. Go for residual life assessment, which gives you the moral aging, the state of what state the plant equipments are running. Then in order to assess the turbine, go for a steam path audit. Then performance evaluation test, which entails everything about the power plant. The performance of the power plant. Then the piping in another area where losses are taken. So the entire power plant can be mapped in these 6 areas through the various techniques of like residual life assessment, audits, performance assessment, water audit, which are directly affecting the life of the plant. And a very good menu card can be developed, which can give a actionable point in the coming days of the power plant for its maintenance and upgradation. So the few of the retrofit solutions which I have shown here are very much known, that we can go for a small retrofit like only HP or IP or LP. A small intervention can give a improvement of even up to 5% of heat rate of improvement, which is a bigger. And if you go for entire shaft line, which is when a plant achieves 25 year, wherein the maximum deterioration has taken place, you can revive up to the nameplate level also, nameplate ratings also. And such retrofits have taken place very recently and very successfully in one of the NTPC power plant, that in Ramagundam, 3 into 200 megawatt units they were running at least 10 to 15% less of their nameplate rating. They have been brought up to the nameplate rating parameters, and even the heat rate has also improved. So the upgradation in boiler can take place by improving their quality of material, which can reduce the outages, etc. So these things are very much available and in the market. So this was about the R&M, but just 2 minutes I will take. As we touched about the digitalization, is that the operation and maintenance practices today cannot go in silos. The various decision making cannot go in silo. So therefore, the digital impact today, based upon the AI, has to come in, which will be other. I have seen that other panelists will be discussing. But then, because of heavy asset entities, we need to have entire information on one table. If not one table, at least in a 4 or 5 places, which matters, which affects in decision making, and which gives us a timing to take decision. Based upon that, instead of only operator taking decision to ramp up, ramp down, and the damages or the outages taking place, or the coal coming in, which coal to be used, which is better, which will is going deteriorating, which everything is costing us. So by the digitalization method, we can control the uses of coal also, and also the boiler outages. Those things are also, they're just an example I am telling. So digitalization is other thing which I am for, and I'm supporting it for it. This will give us a big help toward developing a better operation and maintenance practices. So ultimately, these will finally give us a benefit towards performance optimization, which you can see here. A digital twin, which is today it is called a complete plant digital twin, is developed, or it can be developed in, say, vacuum system or the boiler operating system, which data can be brought in over there and can be played with to see the deterioration area and the best, which is giving us maximum loss, and those area can be addressed immediately. So just in nutshell, and the benefits are very much clear, that the things can be simulated, the early warning can be taken, failure can be preempted. So those things are very much up, and they are coming. They are already in the market. It is being used also in silos, but then of course, it needs lot of background work and lot of involvement before we reach to the final point. So naturally, many other speakers will be talking about it. So with this, I really thank you very much about the entire session, which have been set for the upliftment of the power. I mean the power scenario in the country, and this was my take. Thank you very much for your patient listening. Now over to the session coordinator, please. If any question is there, I am here, or as you decide, I will be supporting accordingly. Mr. Chandrasekhar.
Mr. Chandrasekhar, if any questions, and also I would request all the attendees to please key your questions into the Q&A box, if any, so we could take that up as well.
Thank you very much, Mr. Prabhat. You have practically covered. In between, I was thinking of asking putting some questions, but in the subsequent slide, you have been answering it also. So thank you very much. I have only, as far as I am concerned, my take would be, rather it is my individual take, even though I am no more in the active career now, would be that instead of waiting till the end, it is better that there is a continuous process on R&M. That's what you touched upon.
Yes, this one.
Rather than waiting for its lifetime to go. And so that's a very good feedback for all the attendees, that R&M is a continuous process. It is not an end product. And we have to continuously do that. I have only one thing which if you can share, if not now, at a later date. In one of the slides, you mentioned that the modern thermal power plants has an efficiency of 35 to 49%. If you could kindly share some of the power plants which is maintaining a very high efficiency of that type, which the existing thermal units can set up a benchmark of visiting that plant and see what more things can be done in that. That's just only a data. And second thing, of course, would be you have touched that R&M has improved upon the heat rate cycle and the auxiliary consumption. Is there any plant which has gone for a major R&M worldwide? I'm sure it is not in India, where things they have improved upon the efficiency also, other than the heat rate cycle. If you have, you can share. Otherwise, you can share it later also.
Yes, I am really proud of sharing it, that I have been I've been the part of one of the such overall in India itself. I mentioned in between that very recently NTPC Ramagundam, 3 to 200 megawatt. They are the old vintage plant of Ansaldo Mech.
Yeah.
And incidentally, I have started my career from there itself. I joined in NTPC Ramagundam. So those were the building days, the built-up days of NTPC Ramagundam. And I have been part of initial operation. So I have seen what way the people struggled that time. And during the entire period of operation, as I could have been connected, because it has been my first plant, there have been always some issues, one issue or the other. And ultimately in the last 5-6 years, please don't take the numbers, but then there has been a huge performance deterioration. The plant was operating, it was a 200 megawatt unit. It was continuously operating around 160 or 170 megawatt, not more than that. So this NTPC took this R&M. Of course, I was, in fact, I was the whole-time director in NGSL, NTPC Power Services. So during that period, it was started. Of course, thereafter I left. But I really feel very proud of this moment, that only a month back, the third unit has also been commissioned. And all the 3 units are now operating at a much better heat rate. And as you said, talked about the efficiency. Of course, efficiency, I do not qualify to share any number with you. But heat rate, I can share that it has improved and it has achieved the nameplate numbers. And even better, because as I said, that operating is also possible, which we have achieved I was also a part of that in Gujarat State City Board. That is the Ukai and Vanagbori plant. So there again, it was a 200 and 210 megawatt units. So there it has been operated. And there are few more I can share with you in our offline connection, because I have spent quite a long period in operating and upgrading the power plant. Even we have upgraded a 110 megawatt unit to 120 megawatt. So there the heat rate we have achieved up to 10% of improvement. So many examples are there in India itself.
Thank
And
you.
worldwide also.
Yeah, if you have any data, definitely share, because
So
I'm also I have been
plant.
also an NTPC
Okay,
from Vindhyachal and others. So I'm aware of what
Ah.
NTPC does, and it has been a wonderful.
It will be nice to get connected later on. I can share the numbers also with you.
Sure, sure. Thank you very much,
Offline.
Mr.
Thank you.